Here's the third method that we can use to prove that two triangles are congruent to each other, and that is SSS. So the SSS theorem stands for side, 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 and it's exactly what it says. If you have three pairs of corresponding sides that are congruent, then you will know that the triangles are congruent. They have to be. So here's an example where we have triangle ABC, and I will just go ahead and label triangle ABC. Now let's take a look at AB. It's got one tick mark right there, and so that means that it is congruent to this side here, DE. And take a look, A is kind of the most acute angle. This one right here, this little angle is about the same as that, so I'm going to assume that A and D are corresponding pieces. And so if I go across this one with one tick, it goes from 1, then the one that has 3, and then this one right here has 2 tick marks. So A, B, C goes from 1 to 3 to 2. So I'm going to label this in corresponding order, corresponding to triangle DEF. And the reason is by side, side, side. AB is congruent to DE. BC is congruent to EF, and then AC is congruent to DF. So these are congruent by SSS. Here we're looking at two triangles, and we don't have any tick marks to show us what's congruent, but we do have side lengths, and the first thing I notice is that I see 1.7s, I see 2.3s, and I see 2.4s. So I do have three pair of sides. So these triangles are congruent. Let's go ahead and make some statements. The first one we can say is that AB is congruent to ED because those are both 1.7 meters. And then AC, which is 2.3 meters, AC is congruent to DF, which is also 2.3. And last but not least, that leaves BC, which is the 2.4. So BC is congruent to EF. And so now that I have three pair of sides, yes, the triangles are congruent by side, side, side. Because if I have three pair of sides that are congruent to three other pair of sides, the triangles have to be congruent. Here's a pair of intersecting lines that then create a pair of triangles, and this is a good exercise in corresponding parts. So you can see that we have measurements. For example, we have DH, which is 12 centimeters, that's the little guy there, and looks like FH is also 12 centimeters, and we see a pair of 24s and a pair of 20s. So we can say yes, by SSS, side, 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 these triangles are congruent. We're going to make some statements though, and let's line up corresponding parts. Let's talk about the DH segment, and let's name what DH is congruent to as a matter of explaining. DH starts at the big obtuse angle and goes to the center. So this one here, which is HF or FH, we got to get it in the right order. So since we started at the obtuse angle for DH, I have to start at the obtuse angle, and that means point F. So DH is congruent to FH. Ooh, don't need to put the congruent squiggly over FH. Let's make that a line segment. And now let's talk about the longest side, the 24 side. That's this EH right here. And in order for me to get the points in the right order, if I want to start and call it EH, E is the little pointy acute angle out on the outside, and that's this one here, G. So since this was EH, I started at E, now I have to start at G, and it's congruent to GH. And the last one is ED, and ED is in the same place as this 20 centimeter segment here, which is GF. If we called it FG, it wouldn't be in the right order. So we can make a statement about the triangles being congruent. Triangle, let's call this DEH. triangle DEH is congruent to triangle. Now, without even looking at the drawing, I can probably get this in the right order now. DE is in the same order as FG, and it looks like the last letter is H. DEH ended in the middle, so does FGH, has to also end in the middle, and these letters are now in corresponding order. We're going to apply side, side, side and use it to solve this problem. And so this problem presents us with Lexi buying a pair of matching triangular pendants. And so if they're matching, we assume that the triangles are congruent. And so we can see that this has two legs that are 3 centimeters. And this one also has two legs that are 3 centimeters. In order for the triangles to be congruent, then this side, which they're labeling as BC, must be the same as this side right here, which is labeled KL. So the question is asking, for what value of x can we use side, side, side? In order for me to use side, 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 these two sides have to be congruent, and we will simply write the equation that says 4x minus 6 must be equal to 3x minus 4. We'll go ahead and solve that for x. I'm not going to solve it here because I'm assuming we can solve a two-step equation and find a value of x that would make these two sides true. Here we are looking at a similar problem, and Adeline is making a design using these triangular tiles. And if we're trying to show that the two tiles are congruent, you'll notice we have 4 inches, 4 inches, 4 inches, 4 inches. This one has all 3 sides. There's not a single angle given to me, but this is an equilateral triangle because all the sides are the same. But notice that if I have 4, 4 on this side and I have 2 4s on this side, I have to use something that has 2 sides. One possibility could be side angle side, but there's not a single angle in here. So that's not going to work, which means we're going to have to use side, side, side. And that means that if these two are 4 and they match up to a couple of 4s, this side right here has to be worth 4 inches because that's how long the third side is. And we just have to write an equation that lets 3x minus 11 be the same as that other 4-inch side. And we actually have to solve that for x. I'll let you solve it. And they're not asking us how long the side is. I know the side has to be 4 inches. The question is, what's the value of x in order to use side, side, side to show these two triangles are congruent? This question is really important because you're going to be asked to try and reason if you can conclude that two triangles are congruent given a certain circumstance of information. Take a look at this question. Can you conclude that two triangles are congruent if we have 2 pairs of corresponding sides? Now, we don't have any theorems that tell us SS will work. We either need an included angle, so I need to know an angle in the middle, or I need to know a third side. Just knowing 2 sides isn't going to be enough. An example of this is if I drew 2 triangles that had, let's say, a 4-inch side and another 4-inch side, I could draw this triangle a number of ways. I could make that 4 inches and this 4 inches, and this could just be a really obtuse vertex angle up there. And you can see that these 2 triangles are nowhere near congruent. So just knowing 2 sides isn't enough to conclude that 2 triangles are congruent. I either need to have this included angle right here, which if I knew this angle was congruent to this, then these 2 triangles would have to be congruent. And of course, this right here would be a lot more acute. Or you have to have a third side, because however long this side is right now is not the same as this big old long side down there. So no, 2 sides is not enough. We're going to prove that these 2 triangles are congruent, and we're going to explain our reasoning, and I'm going to list the reasoning out in some steps. So if I take a look here, I've got actually what's a shape that's called a kite, which means these 2 legs here are congruent, and it looks kind of like a kite because these KG is the same as LG because it's got these 2 little tick marks on it. Let's go ahead and make some statements. We're going to make 3 statements. There's 3 statements that are actually given in this figure. The first one is that JK is the short side of the kite up here, is the same as JL. They have 1 tick mark through those 2 line segments, JK and JL. Let's go to this one, KG, which is in the same place as LG. KG is congruent to LG, and that's the second statement. So now I have a side, and I have a side. And 3, the question is, what's the other side? Well, the third side of the triangle is GJ or JG. But you'll notice that it's the exact same side on both triangles. It's a shared side. And whenever you have a shared side, we have that reflexive property that says anything can be equal to itself. So JG is congruent to JG. And if I had to provide a reason, it's the reflexive property that says that it's equal to itself. And that right there is a third side. So the triangles are congruent by side, side, side.